Hi. I work on Spirent's data center infrastructure test solutions. So that's our traffic generators for 10 gig, 40 gig, 100 gig, but also our virtual traffic generators so that you can now also test into the hypervisor level, because there's no simple Ethernet plug that you could hook up our tester there, and emulation of protocols as well. And I wanted to highlight a couple challenges we see in massive migration from 1 gig servers to 10 gig servers in the data center, and what kind of challenges there are. So the first area is around interoperability. There's some great public independent tests out there that test interoperability of different devices. So one example, Network Test did this test for HP, where they took a typical data center setup with access distribution and core. And on one side, they had all Cisco equipment. On the other side, all HP. And this test is publicly available. If you Google HP Cisco interoperability, it'll be the third one down. And they did a really thorough test around 13 protocols, from VLANs to jumbo frames to OSPF v2 and OSPF v3 for IPv6. And it really proved that this can really nicely interoperate. But if you look a little bit ahead into moving the data center to 10 gig Ethernet with convergence and multipathing, there's a slew of new protocols. You have Trill, you have SBB, you have part standards, and you got complete proprietary fabric solutions. You got OpenFlow coming up. You have FCOE. There's different versions of FCOE. DCBX, there's 2 different versions that are being implemented. You have different priority flow control mechanisms. Not every switch does it exactly the same. So there is a tremendous amount of interoperability testing that needs to be done in a multi-vendor environment. And Spirent, and that's where the Toblerone comes from, is kind of the Switzerland in interoperability testing. Because last year we participated in a large shortest path bridging interop event where Alcatel Lucent, Avaya, and Huawei and Spirent came together. And here in the middle, it's kind of hard to see, but this is also publicly available if you search for this with all the details. There was the physical network setup, and then around it, Spirent emulated another 200 SPB nodes to add some scale and load and realism to it, and then we pumped traffic around it. And what I meant with the Switzerland comment is that a lot of these vendors use our equipment to do all their testing before they go to an interop event. So the RFCs they leave some space to how you implement certain protocols. So it's not always guaranteed to work. But if everybody uses our tester beforehand, they have a very good indication that it will actually all link up and establish neighbors when they do these interop events. But so this is again a great interop test. But if you think about all the other protocols and putting FCOE over this and offloading of hypervisors and different hypervisors and OTV and Lisp and VXLAN, there's so many protocols that it almost makes this great test look like a basic test. Second area is that we see as a hurdle is around performance. You need to, if all servers go from 1 gig to 10 gig, and multi-core technology and many VMs, the load doesn't just go up 10-fold, but it actually goes up 100-fold. Because on 1 gig, longer time ago, with only few VMs, the load wasn't that high. But with multi-core technology, you can put so much load, it creates so much I/O, that it really creates challenges around performance. So to prove performance, there's a lot of independent public tests available that show how great devices perform. But as many public tests there are, there's also equally as many different traffic patterns to show the device off in its best light. And it's sometimes hard to do comparisons. You look at 2 charts, they say 100% throughput, low latency, and you think it's the same. You can compare the latency number, but it is really a world of different in a test. And a specific example of that is the type of traffic. If you look in a data center, every 10 gig Ethernet port is going to have a bunch of VMs around it. So you're going to have many MAC addresses. You're going to have many islands of applications. So the traffic pattern you want is the hardest one, the most stressful one on the fabric, and that is sending traffic from every port to every other port. And a lot of reports out there are only port pair. So if you have 100 ports, it's 1 to 51, 2 to 52. And that is a lot less stressful test than one that has full mesh traffic generating to all ports at the same time. So we highly recommend to use full mesh traffic. And one great example is a test that came out on Monday this week, where Arista with Spirent Test Center tested one of their high-end switches with 384 ports of 10 gig, fully loaded, 100% throughput, and they measured the latency with the full mesh pattern. And here you see it did really well too. And that's the other thing I wanted to highlight is that the latencies keep going down. You know, a couple of years ago, routers were hundreds of milliseconds. Now these core switches that also have layer 3 functionality, you know, layer 2 and layer 3, they have a single-digit microsecond latency on average. And it just continues to go down.
When you measure latency, is that the last bit in till the first bit gets out?
Wow. That's my next slide.
Thank you.
I didn't tell him this beforehand.
How hard was it to do the 1500 port Q-fabric test?
I have that on the next slide too. Okay. But and those are all my slides, by the way. Those are the only ones I have.
I have a question. What's on the next slide?
Here's Q-fabric, the 1500 port test. And that's actually all I have. You know, I don't want to do more slides. But let's do the latency measurement, first in, first out. So, you know, no two reports are the same for traffic patterns, but also no two reports are the same because of the latency measurement method. So, you know, in the old days when they made these RFCs, 10 years ago, you either had store and forward switches that buffer the whole frame and then switch it on, and you had cut-through switches that you use. You look at the header, you see where it goes, and then you start passing it on before the end of the frame is in. You know, it comes out the other end already. And that works best if it's the same speed. You know, if you have 1 to 10 gig, or 10 to 40, you need to buffer the whole frame. Today, there is a switch silicon out there that can run in store and forward and in cut-through mode. So last year, the industry kind of posed a challenge on how we've been doing this benchmarking for over 10 years. So what you see is, let's take one of these switches here that can run in both modes. You know, the left is store and forward and the right is cut through. And here you see that store and forward with large frames is actually faster than cut through. And this kind of broke the norm, because normally cut through switching is always faster than store and forward. So what you started seeing is that these reports were coming out comparing two switches where one was running in store and forward and the other in cut through, and people compare the results. It's perfectly fine to test cut through and store and forward on the same box and point out how they are different. But if you're going to compare two switches, you can't use two different measurement methods. Because in store and forward, our test equipment...
You can if you are trying to diss your competitors, which most of the tests are all about.
Yeah. So we make the equipment, and we're not responsible for how you use it per se, but we do have recommendations. And I think in general, it's probably better to do a thorough test of one switch than try to do competitive sponsored tests. But here's a good example of how one of those switches that can run in both modes, where they've used the same measurement method to compare how they performed. So here the left is cut through and the right is store and forward, and both were measured in FIFO, and first in, first out, to have an objective comparison without the tester subtracting the insertion time of the frame. And there you see that the store and forward is significantly slower than cut through. Yeah, but here it looks like it's faster, right? But That's because the switches are so fast nowadays that the measurement methods that were developed 10 years ago don't take that into account. That's just an example to really look at the measurements and ask about how they were done.
I don't think a lot of people understand that last in, first out is a real misnomer.
Yeah.
Because you're actually measuring from the back of the packet that inbound to the front of the packet exits the switch.
You're measuring the latency of the switch.
Yes.
Yeah.
But as he says, comparing it FIFO for cut through doesn't compare to a LIFO. Yeah, straightforward, and you get really distorted perceptions.
Yeah, if you take our tester and you plug the transmit into the receive and you take the switch out of the equation, if you run in store and forward mode, we will actually display you minus a microsecond latency for 1500 byte frames at 10 gig. Because that's how it's supposed to work. But then if you put a switch in between, that's a microsecond or two in latency. It looks a lot better than it really is. So on your question on the QFabric test, how hard was that? It was a lot of heavy lifting. You think about cabling 1,500 ports. That takes 2 days. Just to cable it and not make it all look nice.
It's comparable to that domino thing that they put up and then.
Yeah, on the test equipment, it's a real challenge too, because again, here we wanted to do the same thing with Juniper and the independent test lab, is to run a good test. So not just a port pair test, but go full mesh from every port to every other port. And then if you start thinking about it, it's 2.3 million flows that you have going every fraction of a second. And all of those, we need to measure latency down to 10 nanoseconds in resolution. So this was quite a feat, and we're really happy with this test as well, that we were able to pull it off at this scale.
Who sponsored this test?
Sorry?
Who sponsored that test?
This was an independent test, but it was done by Juniper, commissioned by Juniper. But they commissioned network tests, and they independently verified this, and they used our equipment for that.
Now, if you do full mesh, then obviously you will get some output blocking. Because if two senders send to the same output port, obviously a queue builds.
Yeah, that is
how do you account for that?
That is a great question.
And that's it.
Yeah, so that is a challenging task for us as test equipment manufacturers. We need to make sure that the test pattern we generate does not create congestion or head-of-line blocking. So our cards are perfectly synchronized in lockstep down to 10 nanoseconds to prevent two frames arriving at the same time.
So you
That's why that test is so much more stressful, because you're actually testing if they can push that traffic through a line rate in the right order.
Yeah. So that is another thing, right? The definition of an RFC 2544 latency test is that it's run at the throughput rate. And the throughput rate is the highest rate you can achieve without frame loss. So you first establish how high you can go without loss, and then you measure latency at that most stressful point.
Well, making sure that you don't generate output queues.
Yeah.
Wow.
So, do you want to elaborate on that question?
Sorry, on oh yeah, so what I wanted to bring up, the last challenge here is if you look ahead, like system testing, Juniper did a great job here proving at 1,500 ports that their system can really scale. This is 4 to 5 times higher in density than any test that's been done before. With lots of 40 gig in the aggregation too, so it really takes the point of view of loading it up from the servers. And then if you look at technologies like SDN and OpenFlow and all the different ways you can do things, somebody is going to have to do those system tests to prove how well that all will work. So it's Spirent to help out here. We have an OpenFlow test solution under development to do these scale-out tests. And another interesting thing on the latency, that I forgot to mention, at Interop, we're also going to be demonstrating super low latency switching together with Gnodal. At their booth, they're going to have a demo with Spirent Datacenter is showing possibly even lower latency than anything that's been shown before. So to summarize, there's quite a few challenges going to high-speed Ethernet. It's not just making that 40 gig direct attached copper cable between two switches to talk. It's really around interoperability, performance, and scale. Those are the hurdles, and testing will really help the industry to overcome this.